Okay, on this video, we're going to take a look at numbers 6 through 11 on the final exam review worksheet. So on number 6, I'm starting with a terminal ray that passes through the point 12, -5, and I want to find all 6 of our trig functions using that. All right, so to draw a triangle, I want to go through this point right here. So I'm going to go over here to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Extend that a little bit. And then I'm going to go down my y-axis, -5. So 1, 2, 3, 4, 5. And so I've got this point right here that my terminal side is going to go through. And so to draw this triangle, whenever we draw a triangle like this, I'm going to put my x side of my triangle on my x-axis. You can see that in my black pen. And then I'm going to put y not on y, and then I'm going to attach them to make my triangle. And when I do that, it gives me this angle right here. This is going to be our theta angle right there at the origin. So x is on x, y is not on y, and theta is at the origin. And I know that this side right here is 12 because we went 12 on my x-axis. And I know this side right here is 5. I'm going to call that -5 because we're going in a negative direction. So since that one's going down. So if you're ever going left or down, you're talking about a negative side of a triangle. So here's my right angle right here, and I've got a 5, 12, 13 triangle, so my hypotenuse is going to be 13. And remember that your hypotenuse is always the longest side, and it's also always positive. So no matter which direction your triangle is going, that hypotenuse is always going to be positive. All right, so let me label these sides. Let's see here. We've got my opposite side here, we've got my adjacent side here, and we've got my hypotenuse over here. And all of that's in relation to this theta angle right here that we drew at the origin. All right, so to help me get started, I'm going to work with SOHCAHTOA. We'll come back to SOHCAHTOA again a little bit later. And so I'm going to start with sine. And we always put an angle with sine, so that's going to be sine theta. And my fraction here is going to be my opposite over my hypotenuse. And then I'm going to work with c. So c is for cosine. Again, put an angle with cosine. So theta, working with our theta angle. And that's going to be my adjacent over my hypotenuse. And then finally, for my third one here in this column, I'm going to have tangent of theta, and that's going to be my opposite over my adjacent. So we're just setting up these 6 trig ratios. So there's the first 3. And then for my last 3, I'm going to set up my reciprocals. And so the reciprocal of sine is cosecant. I'm just going to flip this upside down, so that's going to give me -13/5. And that negative's kind of floating out in front there. And then I'm going to work with secant. Secant's the reciprocal of cosine. So that's going to be 13/12. And then cotangent is the reciprocal of tangent, and that's going to be -12/5. And so those are our 6 trig functions. Just again, be careful of which quadrant you're in so that you know which ones are going to be positive and negative. Very good. All right, on number 7, we are trying to find all the 6 trig ratios that go with our theta angle of 5π/3. Before we do that, let me go ahead and just draw a picture of my quadrant 1 that I'm going to be working with a lot for the next few questions. And the other thing that I'm going to draw to help me out with a lot of these next few questions is my all students take calculus. And I'll come back to that in just a second. But for right now, let's get our angles going in here on my quadrant 1. And so this one's going to be π/3 and π/4 and π/6. We're working mostly in radians here. And 0 pi and π/2. And so when I do this, I like to think again, we're talking about the unit circle. So each point is 1 unit away from the origin here. So that's going to be 0, 1, and this is going to be 1, 0. And so just to kind of save me a little bit of time here, I'm going to go with the shortcut on filling in quadrant 1. And so when I do that, I'm going to start up here at 0 on x, and I'm going to go to 1 on x, and I'm going to get bigger as I go. So that's going to be 1, 2, 3, and they each get a square root, but the square root of 1 is 1, and they each get a denominator of 2. And then I'm going to move over to my y's, and with y's I go from 0 here up to 1 here, so I'm going to get bigger as I go this direction this time, so that's going to be 1, 2, 3. And again, they each get a square root. The square root of 1 is 1, and they each get a denominator of 2. And then I'm going to go ahead and write my tangent values out here on the side as well, which you can always find tangent by putting y/x, but just to save me a little bit of time, I just kind of memorize my tangent values and write them out here on the side. And then the last thing that we may need are our values over here at pi. So pi is going to be -1, 0. and down here at 3 pi over 2, or negative pi over 2, and that's going to be 0, negative 1. All right, so it gives me a lot of my quadrant 1 and my unit circle that I can work with. And then let me remind you about all students take calculus. This tells me where things are positive. So in the first quadrant, they're all positive. In the second quadrant, sine is positive, but cosine and tangent are negative. And down here, tangent is positive, sine and cosine are negative. Wrap that in with the third quadrant. And then cosine is positive here, which means sine and tangent are negative. And so again, you can take that quadrant 1 and kind of apply it to all 3 quadrants, or the other 3 quadrants, I should say, and using those signs with your all students take calculus. All right, so now I can get down to number 7. So with number 7, we're working with a theta angle of 5 pi over 3, and I want to find the 6 trig functions to go with that. So let me start with the sine of 5 pi over 3. All right, so just for a minute, let's talk about where 5 pi over 3 is. So when I'm looking at my unit circle here, I know this right here is 2 pi, or 6 pi over 3. So 5 pi over 3 is going to be kind of right here in the fourth quadrant. And so in the fourth quadrant, I know that sine is negative, and I'm working with pi over 3 here for my reference angle. Let's go ahead and write down that my reference angle here is pi over 3. And with sine, I'm working with y. I should write that down up here too. So on this little chart here, sine is y, and cosine is x. All right, so I'm working negative because I'm in the fourth quadrant with sine. And then at pi over 3, my y value is the square root of 3 over 2. So my sine value is going to be negative square root of 3 over 2. All right, and let's find the cosine of 5 pi over 3. So with cosine in the fourth quadrant, I'm working with a positive value here. I'm going to go ahead and put a little plus sign right there just to remind myself you don't really need it. And then with cosine, I'm working with my x value. So my x value is going to be 1/2. Again, you don't really need the plus sign there. And then finally, with my tangent for this part, I'm going to work in the fourth quadrant where tangent is negative, and I'm working at my reference angle of pi over 3, and at pi over 3, I know my tangent value is the square root of 3. Right, now this one did ask me to find the reciprocals, and the signs are going to be the same. All I need to do for my reciprocals is flip this upside down. So let me start with the cosecant of 5 pi over 3. So when I flip that upside down, you can memorize these values if you want to, but that's going to give me negative 2 over the square root of 3. And I'm going to rationalize that denominator. So that's going to give me negative 2 square roots of 3 over 3. Right, on this one, our secant value is the easy one. So first of all, since cosine was positive, secant is also going to be positive. And when I flip 1/2 upside down, I just get 2. And then finally, with my tangent value, I am going to have to do a little bit of work to get to cotangent. Oops. So cotangent of 5 pi over 3. I'm going to keep my negative sign, and I'm going to flip this upside down. So kind of envision a 1 being on the bottom right here. So when I flip that upside down, that's going to give me 1 over the square root of 3. And I'm going to rationalize that denominator. So that's going to give me negative square root of 3 over 3. Just like that. Good. Okay, on number 8, they give me 3 values to work with. I'm going to keep my quadrant 1 where I can see it right there because I'm about to work with a lot of those. Let me start with the cosine of 3 pi over 4. All right, so let's do a little work with this. Let's see here. I know 3 pi over 4 is in the second quadrant. This is 1 pi right here, or 4 pi over 4. So 3 pi over 4 is just going to be right here in the second quadrant. And I'm working with a reference angle of pi over 4. So remember, your reference angle is just going to be 1 pi over that denominator that you're given right there. So in the second quadrant, I know that sine is positive. Move that down a little bit. Sine is positive and cosine is negative. So since we're answering a cosine question here, that's going to be negative. And then I'm working with that reference angle of pi over 4. So cosine being x at pi over 4 is going to give me the square root of 2 over 2. All Right. Also on number 8, they ask you to find the sine of 5 pi over 6. Let's kind of do the same prep work here. So 5 pi over 6, again, I know this is 1 pi right here, or 6 pi over 6. So I know 5 pi over 6 is going to be just 1 back right there in the second quadrant. So we're still working in the second quadrant. And my reference angle is going to be 1 pi over this denominator that we're given, so over 6 right there. So in the second quadrant, I know that sine is positive, and I'm working at pi over 6, and I'm looking for my y value since sine is y, so I'm going to have positive 1/2. And again, you can put a little plus sign there if you want to, or you don't have to, your choice. And finally, I'm working on number 8 with the tangent of 3 pi over 2. So 3 pi over 2 is one of my quadrantal angles. It's the one that's down here on the bottom. Here's 3 pi over 2 right here. And we said that that point was 0, -1. So if I take my y value and put it over my x value, which is how we find tangent, so tangent is y over x, this is going to give me a number over 0. We can't ever divide anything by 0, and so that's where we fall into that undefined category, or that category where we'd end up with asymptotes on a graph. Right, on number 9, we're working some more of these, but now we get into kind of some coterminal angles and some reciprocals and things like that. So let's start with the cosecant of -5 pi over 4. So your choice on how you want to deal with -5 pi over 4. I'm going to just remind you that when we measure a negative angle, we want to go in a clockwise direction. So I'm going to measure my angle this way. And so again, I still know that this right here is pi, or in this case, -4 pi over 4. Negative pi right there. And so I'm going to keep going, and I'm going to go one more this direction right here to -5 pi over 4. It's going to be right there. You can add 2 pi to it if you want to and turn it into a coterminal angle. It's completely up to you. Either way, we're going to be working in quadrant 2, and I'm going to be working with a reference angle of pi over 4. All right, if we're working with cosecant, I'm going to start by finding the sine of -5 pi over 4. So in the second quadrant, I know that sine is positive, and I'm working with my y value right here at pi over 4, so positive square root of 2 over 2 for sine. So remember that this negative right here only tells you how to graph the angle. It doesn't have anything really to do with the positive negative over here. This tells you how to graph the angle. Then use your all students take calculus. All right, we're not looking for sine, we're looking for cosecant. So I'm going to flip this upside down and rationalize my denominator. And so that's going to give me 2 square roots of 2 over 2. And I can let those cancel out, leaving me just with positive square root of 2. All right, also on number 9, they ask me to find the cotangent of 11 pi over 6. All right, so let me start by graphing 11 pi over 6. So when I'm working in sixes, this right here is 6 pi over 6, or 1 pi. This is 9 pi over 6, or 3 pi over 2. And then this one's going to be 12 pi over 6 right here, or 2 pi. So 11 pi over 6 is going to be kind of right there. All right, so I know that we are working in the fourth quadrant, and I am working with a reference angle of pi over 6. So again, kind of like that last one, I'm going to start by finding the tangent of 11 pi over 6, just because that's a little easier on my unit circle, and then I'll go back and flip it upside down for cotangent. All right, so in the fourth quadrant, I know that tangent is negative. Go ahead and jot that down. And then at pi over 6, I know that I have a tangent value of the square root of 3 over 3. So tangent is negative square root of 3 over 3. So cotangent, I'm going to flip that upside down like that. And rationalize my denominator again. That's going to give me negative 3 square roots of 3 over 3. And I let those 3's cancel out right there, leaving me with a negative square root of 3. And finally, on number 9, they asked me to find the secant of pi. So pi is still a quadrantal angle. So let's go over here to pi. And that's going to be at the point -1, -1, 0, right there when I'm talking about pi. All right, so I know that secant is the reciprocal of cosine. let me find the cosine of pi first. So cosine is my x value. That's going to be negative 1. And you can kind of, again, envision that negative 1 being over a 1 right there. So I want to flip that upside down. And when we flip that upside down, that's going to become negative 1 over 1, which is still just negative 1. So negative 1 kind of is its own reciprocal. All right, on number 10, we are given a sine value, and we are told which quadrant to draw that in. So we're done with our unit 1, or quadrant 1, on our unit circle for just a few minutes. I'm going to move that out of the way. And we will take a look at number 10. So on number 10, they tell me that the sine of theta is 1/3, and they're telling me to draw my triangle between pi over 2 and pi. All right, so let me go right up here and draw my triangle first. So I know pi over 2 is right here. I know pi is right here. So I'm going to draw, again, x on x, y not on y, and I'm going to put theta at the origin right there. Okay, so back to my SOHCAHTOA that we were using earlier. By giving me sine, they've given me my opposite side and my hypotenuse. So from theta, this is going to be my opposite, and this is going to be the hypotenuse. And again, remember the hypotenuse, oops, you can see, the hypotenuse is always going to be positive. All right, now this one's not a Pythagorean triple, so I'm going to use Pythagorean theorem to help me find my missing side. And the missing side I'm missing right here is x. So I'm going to say leg squared plus leg squared equals my hypotenuse squared. So x squared is going to equal 8. And if I take the square roots of both sides and take out my perfect square number there of 4, that's going to give me 2 square roots of 2. Now be careful because this one's going to the left. That's going to be a negative 2 square roots of 2 right there. All right. This one asks me to find the 5 remaining trig functions. I'm going to go ahead and write down all 6 because I'm going to use sine to help me with my cosecant here in just a minute. And this also goes along with your all students take calculus. Since we're in the second quadrant, my sine should be positive and cosine and tangent values should be negative. So it's a good way of checking your answer. All right, so for cosine, I'm going to do my adjacent over my hypotenuse, which did come out to be negative. And for tangent, I'm going to do my opposite over my adjacent. Now on this one, I'm going to need to rationalize that denominator, but I only need to rationalize the square root of 2 part of it. So that's going to give me negative square root of 2. I'm going to pull that negative out in front. And then when I multiply these together, I'm going to keep the 2, and then I'm going to multiply that by the square root of 2 times the square root of 2, which gives me 2. And so 2 times 2 gives me 4. All right, asked me to find all 6, so let's go through and flip these upside down. So my cosecant will be easy to flip upside down. 1/3 will flip over and become 3. And box some of my other answers. The cosine is the one that's going to be a little bit harder to flip upside down because we are going to have to rationalize that. So that's going to start off giving me 3 over negative 2 square roots of 2. And again, we just need to rationalize the square root of 2 part of it. So I'm going to keep my negative out front, and that's going to give me 3 square roots of 2 over 4 down there on the bottom. And then with cotangent, I'm going to go back and flip my original tangent right here so that I don't have to do a lot of rationalizing. And so when I flip that upside down, that'll give me negative 2 square roots of 2 over 1, so just negative 2 square roots of 2. And finally, our last part of this video on number 11 just asked me to find the cotangent of 52.8 degrees. So I'm going to do that on my calculator. And when I put this in, I need to not put in the cotangent because that's not an option on my calculator. So I'm going to put this in as 1 over the tangent of 52.8 degrees. All right, so just like in the last video, the first thing I'm going to check is to make sure my calculator's in degree mode. So go to mode and make sure that you're in degrees first, and then second quit to get back out of there. And then a couple of different ways to put this in, but I'm going to use alpha F1 number 1 so that I have a fraction to work with there, and I'm going to put in 1 over the tangent of 52.8. Again, since they gave me that in degrees, I want to make sure that I'm working in degrees. And let's round to 3 decimal places on that, so 0.759.